Hello and good morning, everyone. I am Elin Ehsani. I started working on natural language processing since my master, so many years ago, and of course recently changed to work with LLMs. Now I am working in a startup as head of AI, which mainly we are working with LLMs. So today I'm going to talk about the product, a bit about the product that we are building in parallel. Also some challenges and some of use cases that we have there with LLM. And I will explain a bit how we are using knowledge graph to help us to have better results and kind of validate our outputs with for LLM outputs. Please interrupt me whenever you have questions. That's fine, or if you prefer, we can take questions by end of the session as well. So what do we do in parallel? So we are working on a product that it is heavily UI based, means that we are actually building a software that gives the possibility to everyone especially in big organization, to align about their goals, activities regarding to strategy. But I know this is very abstract now for you. For me, when someone was telling that strategy, for me it was like, okay, some men in black suits are talking about something, KPIs, for example, and then nothing happens. Like, it was my understanding about strategy, or like I was when I was using the word strategy, was like, okay, my cat has some strategy to waken me up every early morning. So I didn't know what does it mean really, and I was thinking that, okay, organization, they have some strategies because they have to have, they define those, and then just that. And they were, for me, when I was reading some sentences, it was just like, okay, some abstract thing. That's good. They want to do something, but I don't know. What do you think? What does it mean for you? But when I joined the company, then I saw that there are lots of things there. So this product is not just about helping to define a strategy. It's not about that. It's actually about this, that whenever in a top management, they are defining strategies, it doesn't go to below in organization. So no one has any idea what's happening in terms of the strategy of the organization or the company. So those strategies are living in PowerPoints or some PDFs, and it's super hard for everyone, even though they are having some meetings to explain what is that, what does it mean for your unit in the company. It stays so abstract, and tracking who is doing what regarding to those strategies and who should collaborate with whom. Those are always flying on the air. So this product is helping in that sense. It means that it brings the strategy to lower layer of the organization or the company. Plus, it gives a possibility to everyone to collaborate over define activities regarding to that strategies and start collaborating. Well, we are not just doing this, but also using AI. We are generating some content. Means that we need to track closely, real time, the market to show like what's happening regarding to the competitors of that company. Because strategy is not like, even though they are defining the high level strategies, like perhaps once in 3 years, it doesn't change like it, and it shouldn't change like every day, but it's still they need to track almost every day what's happening in market, for example. So what we do, we are in some part we are tracking the market, we are tracking all news, we are tracking what is relevant, what's happening regarding to like competitors or suppliers of certain company that like is our user. But also we are tracking the internal activities. We are having these like AI phone calls that is calling every day, just like Scrum type things, calling like users and asking like what kind of tasks do they have, what kind of obstacle do they have, and we are asking about their plan, and then we are using AI, we are processing those, and we are like creating reports, or like we are giving some notification to user that like something is happening in that unit. So these are roughly our things that we are focusing in this company, not limited to these things that I said, but of course, when we are using LLMs as so first, this is like very high level architecture that we have for our like AI part. So we have like certain resources and data. We have APIs that we are getting some like financial reports for companies. Also, like we are collecting some reviews regarding some product. So collection of like APIs, and like then like we have tools to get like scrape data. And so in the first layer, we are dealing with data. We are doing pre-processing for the data. We are like tagging what is relevant, what document is answering which question. So we are having huge work in the first layer there. That's our foil for the next steps. In the middle stage, we have like in parallel extraction, which means that we are extracting certain entities from these documents, but also we are kind of tagging relevant paragraphs to relevant concepts. It's just like normal RAG that you know, but it's in a way that it has the graph format in it, and in that graph format we are like having related paragraphs, and on top of those entities that we are extracting there. Why we are doing this? Because we have huge amount of data, and we just want to like make it much quicker for our next step to answer certain questions. And also in IP extraction, for example, we are dealing with news that we are getting, and we are extracting certain things from there. So we are using some part of that already in the product, but I would say like 90% of that is going to the upper level, which is IP research part. In IP research part, we have an agentic system that has like access to certain tools, and we are using some graph database. For example, we are using Kuzu to query in the graph and like get some answers for certain questions. Those questions are, for example, related to like what are competitors doing regarding to investing in R&D, for example. So this IP research agent is going through the IP extraction graph and searching for the answer there, and then like returning the answer. This is the most simplest workflow. Then we have like IP validation. IP validation is a mixture of like manual validation plus automatic validations. There are many things there that I will just explain, perhaps 2 or 3 of those. And today's subject actually is about the knowledge graph that we are using that for some part of like our validation. I'm sure all of you know that like challenges with LLMs, we also are facing with those challenges. They are not consistent. In every run, you are getting like different answers, especially if you are like trying to get list of things out of that. So you have certain list. You can't say that you don't know how many like items you are looking for. You can't restrict in that sense. Also, you can't force it to like give you like n number of items. So it's always challenging. And especially in our case, because we need to run this, let's say that quarterly. In each quarter, we don't want to have like different things. We just want to have the same answer coming out. And this is like one of challenges that I'm sure you also are facing with that. Then it's hard to evaluate again because they are especially in subjects like strategy, which is a bit abstract. You always think that it's telling nice things. It's really hard to evaluate because it's not like it's not numeric things, or it's not like very, how I would say, you can tell about a story and it still makes about a strategy and it still makes sense. So this is also like huge problem that we have with LLMs when we are working with a bit abstract things. So what we are trying to do is to make it more like data driven. We are trying to limit like LLMs like material to work is not like what LLM has it inside, and we are trying to focus on the best ability that like LLMs have, and it's like summarizing things, or like making coherent things from existing things. So we are trying to focus on using in that sense. So this is just one small example of IP extraction part, which we are trying to extract strategy-related items. So what do? We have like data sources, as I said, like we have this quarterly financial reports that we are getting from, for example, from FactSet. It's a database for company-related documents. So we are getting those data, and then we have kind of filtering heuristics, means that not all documents are relevant for us. Not everything there is relevant for us. So we are getting like certain metadata out of those, because even though we are using like API to get the data, it still needs cleaning. It's still like you are querying for a certain period of time, and you still see that there are like wrong things there. So we have certain heuristic to filter that data. Then we send it to pre-processing. In pre-processing, basically, we are taking text out of PDFs, and we are getting interpretation for certain graphs. So we are just like making that ready for our RAG system. We are using like RAG checker to just like have a bit of like validation evaluation in RAG system, but also we have a UI that gives opportunity to domain experts in the company, that they are, by using that UI, they are choosing certain type of document for certain type of company. Let's say that company is working in cybersecurity, and then document type is like a quarterly financial report. So domain expert choose these two pairs, and then start writing their own prompt there. So it just, we don't give any prompt to them. They start writing their prompt until they get everything that they want out of that document. So by doing this, we are customizing our prompts for certain domain, for certain type of document, because some documents can talk about something at the end of the document, or like some documents, they are just like presentations that needs different type of prompting. So by doing this, we are customizing prompt based on document type and domain. So we are collecting prompts, and when in our like pipeline, when we have the pair of this domain and document type, we just fetch the relevant prompt instead of like one prompt. Then we have data model. For some people who they don't know about data model, it is the model that define what kind of like data in terms of like metadata we are using in the product, to have coherent model for everyone to use the same, for example, to use the same terminology, to have the same connection and dependencies between let's say variables that we are like using in the product. So we have data model that says when you are defining a strategy, you have like strategy objectives, you have KPIs, you have risk, you have capabilities, you have like, these are like a bit domain dependent things. And then data model says that there is relation between strategic objective or goal and KPI. There is like, and this is basically our knowledge graph. We know that there is dependency between certain like variables here or entities here. So it comes in RDF format, but it doesn't matter. It can come in any other like graph format as well. So after we after we fetching prompt, then we have this health check mechanism that comes through this knowledge graph. So we force our like LLM to follow this structure that we are defining there. So by doing this, like in loop, until it meet all expectation that we have from this health check using the data model, it repeatedly doing check that all dependencies are there, all items are there. So this is one use case that we have for a knowledge graph that we are using here. Yeah, so again, if we go back to the challenges that we have, no need to explain everything. I'm sure you know all this, like the hallucination. It sometimes, as I said, because domain is abstract, you can't really be sure that like this is true or not. Plus, we are like a small startup, like 30 people are working there, and most of the time, and we have to generate this content daily. Sometimes the amount of content is so huge that validating that is super hard and needs to like domain expertise and as I said, like even though you use like knowledge graph, or you use like another LLM to validate this hallucination, it's hard to catch it. So this is with this knowledge graph, as I like explained, we bring a bit of like explainability also, because we can say that we don't hallucinate about the dependency between the entities that we have. They are always true because they have to be true, because they are following certain structure that we are giving there. Then whatever we are building over this, so the results of this pipeline comes in graph format. So we have entities, then we have like relationships. And as I said, these are like validated by the data model. So now we know that like we have kind of ground truths that we can run our algorithms over those graphs, even though we do interpretation using LLMs, but it's still we are running some kind of graph-based tools to get, let's say that the best community out of this graph. Means that let's say that you can just use LLM to cluster like your items, but when we are making this graph based on knowledge graph, and let's say that we run community detection algorithm over that, we are sure that we are doing right things. We are sure that in our clusters we are going to have like right things. This is, as I know, like this sounds simple, but the problem with LLM is that like even though if they make one wrong things, still it's wrong. It's not like you can't trust them 100%, and you can't trust them in partially even. You can't say that they are 100% good doing this. They are like good in everything, but not perfect in like certain things. So that's why like this kind of mechanism help us to push determinism to this like randomness of like LLM world. Yeah, I think I explained this part also there, so I can just go the next. Yeah, I explained this as well. So yeah. So I gave you an example, but I can still park a bit here, because I think the rest might be very familiar for you, but data model and ontologies might be new thing for some of you. So like we have core entities. In this case, it's just for strategy extraction part. We also have those for other things as well. So for example, we say that in a strategy, we have a problem, then we have solution. So each problem needs to follow some solution. That's the like restriction or constraint that we have. So whenever we are producing, whenever we are finding some problem, let's say obstacle, during the activities, let's say that like I told you that we have this phone calls that gathering some feedback from users, from employees. And let's say that one employee says that I had a blocker, I couldn't do these activities. So then we are detecting those obstacles. Then we know based on the data model that now we need to find out some solution for those. And data model tells us that whenever you have solution, that needs to turn to new activity. So each solution should convert to activity, for example. So this kind of like constraint, or let's say that defining some kind of like comprehensive thing help us to always know like what kind of workflow we need to follow, what kind of like path we need to follow to get those out. Yes, I think, for example, another example of that could be that we have a strategy goal. That's one entity that we are finding through this like reports, and then those needs to supported by at least one initiative. And it means that if you extracted this information from one document, you have like a certain goal, but you couldn't find any initiative. So you go back to LLM and you say that, hey, based on this definition, I need to find at least one initiative that support this goal. Then we force LLM to rerun and like we recall LLM to get this answer until we like meet all expectation from data model. Or another one, like when one goal can mitigate multiple risk or single risk. So this is like as previous example, it's not enough to find some risk and then you don't have any goal regarding to those risks. So you need to go back and try to find this information from your document. So yeah, this knowledge graph is actually, even though it brings lots of constraint for UI side, but still it's quite helpful in a way that like whenever we are working with LLMs, we need to have some kind of deterministic or rule-based validation system, and those are perfect for doing that. But of course, you need to have like depend on the use case. You might not always be able to like define certain like knowledge graph. It's fully depend on the use case. So it also like in knowledge graph we are defining certain type of metrics for entities, and we know that like for this entity we need to follow this metric. So these all of this information, or like in our knowledge graph, we define that, let's say that we have a data catalog, which is kind of knowledge graph. We know that like inside certain document, you can find certain information. This comes through the knowledge graph. So whenever we have our like agent, which is looking for which tool to call or which document to use, we are using this information from knowledge graph. Yeah, this is one small use case about IP research. Strategy Graph Insight Engine is the name of this, and here you see a bit simple version of like what we are using. So we have this like agent that is like getting the question in natural language, in like let's say that I'm asking about competitor investment, or I am asking about what kind of revenue this, what kind of changes happen during the quarters in the certain company, and then I just choose. I turn that information that I have from IP extraction to graph, and then I decide based on the question to call, like, for example, which graph-based algorithm. I just gave you example about clustering, that is like community detection. Or in some cases, it's like I have activities that dependent to each other, and I just want to detect that and there is a certain obstacle regarding to those activities, I just call like shortest path to catch like which obstacle is like high priority. So this type of graph-based algorithm, agent decide which one to use for solving certain things, and then like we are getting answer, and like we are refining that with LLM. So LLM doesn't do actually, LLM doesn't find the answer. LLM just like making it beautiful, let's say, or making putting it in nice sentences, but actual work is done in the like a tool part, which is like graph-based algorithms. Yeah, I think that's all from my side. So we can start discussing if you have any question.